Yeah, good morning everyone. We are discussing about a armature reaction in synchronous generator. So we know if the effect of armature reaction, how it will be placed in a various electrical machines, similar to the DC machines. There is armature reaction. Action will be takes in a synchronous generators for different power factors. For different power factors. So what is meant by armature reaction? Means there are two fluxes are there in a machines. Either it is a DC machine or AC machine or DC generator or AC generator or synchronous generator. One flux we call the main field flux and the another flux we call the which one? Armature flux. While the machine starts running after developing of the flux in a armature coils, this armature flux is interacted with the main magnetic field. The armature flux is interacted with the main magnetic field. So the armature reaction is defined as the effect of armature flux on main magnetic flux. The effect of armature flux on main magnetic flux is called armature reaction. Now we will see this armature reaction in synchronous generators for different power factors. So the armature flux and the flux main magnetic flux produced by the which one? Rotor field poles. Rotor field poles. When the current flows through the armature winding of the alternator, a flux is produced. That flux is called a resulting MMF or magnetomotive force. This armature flux reacts with the main pole flux, causing the resultant flux to become either less than or more than the original main field flux. Less than or more than means the armature flux is affecting either decreasing means the direction of armature flux flows in opposite direction to the which one? Main flux, or if the main flux as well as armature flux both are in the same direction means aiding, the resultant flux is going to be increases. So these are happens in case of a synchronous machine. For example, here I am considering a 3-phase 2-pole alternator. My alternator is a which one? 3-phase 2-pole alternator. So these are the two poles. One is a north pole and south pole. It is a rotor of the alternator and it is a stator of the alternator. The rotor of the alternator is excited with the which one? Small DC supply. The winding of each pole is assumed to be concentrated winding, but the effects of armature reaction will be same if distributed winding also used. Means only the armature reaction effects it changes depends on the power factor only, not on the type of the winding we are using. Either concentrated winding use or either distributed winding you can use. Okay, now the effect of armature reaction changes depends on only type of the power factor and magnitude of the current. So the armature reaction discussed here following three conditions. One condition I am assuming a unity power factor, and the other one is a zero power factor lagging condition, and the other one is a zero power factor leading condition. One is unity power factor and the other one is a zero power factor lagging and other one is a zero power factor leading. We know the power factor is a cosine angle between voltage and currents. That voltage and currents are always phase voltage and phase currents only. The power factor can be defined as cosine of the angle between armature phase current and induced EMF in the armature conductors in that phase. In that phase. So the armature reaction at unity power factor. The armature reaction at unity power factor. The direction of a rotation of the rotor is considered clockwise. By applying the right hand rule, the direction of induced EMF in various conductors can be found. The direction of rotation of conductors is taken anti-clockwise with respect to the rotor poles. Suppose that the alternator is supplying a current at unity power factor, the phase currents IA, IB and IC will be in phase with their respective generated voltages. We know the power factor is a unity power factor. Unity power factor means examples. Unity power factor means example pure resistive load. Unity power factor, okay now. The resistive load contains a pure unity power factor. So we know for pure resistive load, the current is always in phase with the voltage. The current is always in phase with the voltage, and whatever it may be the power factor, the flux is always in phase with the current. The positive direction of fluxes I consider here phi A, phi B and phi C are, and each are displaced with 120 degrees. So where the maximum values of current and flux, the flux phi A is along with the axis of OA, and from this one 120 degrees which one, phi B and phi C. But to get a resultant flux, I consider phi A as a origin, and the negative of a phi B is given a written, and the negative of a phi C is written like this. From the phasor diagram, actually each are displaced with, each phase is displaced with 120 degrees. Whenever I constructed this one phi A and phi B, now the angle between phi A and phi B is a 60, and phi C and phi A is a 60, and the angle between phi B and phi C is a which one, 120 degrees. So we know the resultant flux is a minus of phi A minus phi B cos 60 minus phi C cos 60. The cos 60 is the value of a 1 by 2. So the resultant flux I am getting 1.5 times of a maximum flux. We can calculate it for at any degree. Okay. No? So the resultant armature reaction flux is given by 1.5 times of a maximum flux. If the rotor is rotated 30 degrees in clockwise direction, the corresponding phasor diagram is like this. If the rotor is rotates at 60 degrees or 90 degrees or 120 degrees, whatever it may be the rotation of the rotor, always in case of a alternator or in case of a synchronous generator, the resultant MMF or flux is produced is equal to 1.5 times of a maximum flux. 1.5 times of a maximum flux. So the direction of resultant flux along OD, which makes an angle with the horizontal in clockwise. It is observed that resultant flux sets up a current in the armature remains constant in magnitude equal to 1.5 times of a phi m, and it rotates at synchronous speed. When current is in phase with the induced voltage, the armature reaction flux lags behind main field by 90 degrees, and this effect we call the cross magnetization effect, or the flux we call the cross magnetization flux. That means whenever alternators are connected with the UPF loads. Whenever the alternators are connected with the UPF loads, the resultant flux armature reaction effect is a cross magnetization effect. And the another one is a lagging power factor. Armature reaction at lagging power factor. Suppose if the alternator is loaded with inductive load, we know the inductive loads are a good examples for lagging power factor. If it is a pure inductor, the current through inductor always lags the applied voltage by 90 degrees. If it is a pure inductor. So, if the alternator is loaded with the inductive load of a zero power factor lagging, why we call it zero power factor means the effect of resistance is not considered. Here I am considering my load is a purely inductive load. So the phase currents of a three-phase circuits IA, IB and IC will lag with their respective phase voltages. Means IA lags the EA and IB lags the EB and IC lags the EC by 90 degrees. And we can observe from the phasor diagram also clearly. It is a IA lags exactly with 90 degrees with EA and IB lags exactly 90 degrees with EB and IC lags exactly 90 degrees with the EC. Okay, now these are the phasor diagram and the resultant voltages or the resultant flux or the resultant current we can calculate it from the phasor diagram. So this diagram is also called a spacer diagram of a magnetic fluxes at any side because all three are displaced with 120 degrees. All three are displaced with 120 degrees. You can take reference at any one phase and remaining phases opposite direction. Okay, you can close the circuit. You can close the phasor diagram. Again, similarly, previous circuit, it is a 60 degrees, it is a 60 and 120. So, by drawing a vector diagram, this resultant we are calculating. Again, it is also gives a which one? 1.5 times of a maximum flux. So, the direction of armature reaction flux is opposite to the main field flux. Means the main field flux I consider EA in this direction. After consideration of a lagging power factor effect, means after consideration of a my induced currents are 90 degrees lag with their respective phase voltages, the resultant flux is in downwards. The actual flux is in whichward? Upwards. Means these two fluxes are completely in opposite direction. The two fluxes are completely in opposite direction. So the resultant is decreasing. The resultant is which one? Decreasing. The resultant is which one? Decreasing. This type of effect we call a demagnetization effect. This type of effect we call a which one? Demagnetization effect. Five minutes.